Namaste. Welcome back. The next chapter, alcohol phenol ether. Directly moving to the question. IUP is name of a secondary butyl alcohol. Secondary butyl alcohol, you have to know how to write the structure. Secondary butyl alcohol. So what is secondary butyl group? This is secondary butyl group and OH, secondary butyl alcohol. IUP is name 2-butanol. Butanol 2, butane 2, or like that. Butyl group, you know how to write. Normal butyl, isobutyl, secondary butyl, tertiary butyl. I taught you the same. Number 2, question number 2, benzene 1,4-diol commonly called. Benzene 1,4-diol, what is it? This is benzene 1, 2, 3, 4. Quinol, common name. Okay. Number 3, in the manufacture of phenol from cumene, the byproduct formed. You know, cumene, isopropyl benzene. Isopropyl benzene. This is the structure. This is commonly called cumene, and cumene, when treated with air, you are getting cumene hydroperoxide. Okay, 2 oxygen atoms are inserted between the CH bond. This is called cumene hydroperoxide. Okay, and this one decomposed in presence of an acid. OH group and benzene join together to form phenol, and the remaining part is acetone, CS3CO, CS3, acetone. Agree. So the byproduct, okay, in the manufacture of phenol from cumene, byproduct is acetone or propanol. Okay, so that is question number 3. Then question number 4, the correct order of the pK value of pK, it's a term indicating acidity. Lesser the value of pK, more will be the acidity. Higher the value of Ka, acidity more. When we are taking negative log, lesser the value. Paracrosol, paranitrophenol, phenol and ethanol. See, alcohol and phenol, when we are comparing, acidity is more for a phenol, not for alcohol. Okay, so study that idea first. Alcohols are less acidic than phenol. So the highest value for pK moves to ethanol, and the remaining 3 we can compare. What are the compound? Paracrosol. What is it? Paracrosol. OH group, and here there is a methyl group. This is called a crosol, and another molecule is paranitrophenol. Okay, nitro, and another is phenol itself. See, presence of electron withdrawing group increases acidity, and presence of electron donating group decreases acidity. So position of phenol lies in between these two. So lowest pK for nitro, phenol. Okay, number 2 goes to phenol, number 3 goes to crosol, and finally to ethanol. That is order of acidity, decreasing order of acidity. So just the reverse will be the order of pK. Lowest pK, okay, the next phenol, third position crosol, and fourth to the alcohol. So find the respective order. Actually here there is no order, they are giving some values like 10.2, 7.1, 10, okay, like that. So arrange in this particular order. There is a way of answering this question. Question number 5. Question number 5, an alcohol that does not form any turbidity with Lucas reagent at room temperature. You know, Lucas reagent immediate turbidity indicates tertiary alcohol. Turbidity after 5 to 10 minutes indicates secondary alcohol. If there is no turbidity, it should be a primary alcohol. That is a theory. So identify a primary alcohol. You can easily identify. Question number 6, relative ease of hydration of alcohol. I told you in one organic chapter previously, dehydration of alcohol follows carbocation mechanism. Okay, and after binding H+2 OH group, H2O will be detached, so a carbocation is formed, and among the carbocation, tertiary is more stable than secondary than primary. So order of the reactivity also follows the same trend. Okay, relative ease of dehydration of alcohol. Why? Because dehydration proceeds through carbocation mechanism. Tertiary more than secondary than primary. Find the order. Okay, you find the order and tell me. Question number 7, the first step in the acid catalyzed dehydration of alcohol. Yeah, so these two questions are interconnected, so I am going to write. Okay, with a particular example, so that you can easily recollect what I taught. See, I am taking this molecule for dehydration. So first step of dehydration is protonation of alcohol. By giving this lone pair, it is absorbing H+. So that you are getting an oxonium ion. You are getting an oxonium ion. This is the oxonium ion. And immediately that oxonium ion releases a molecule of water. You know how this is possible? Okay. So that this positive charge shifted to here. So the carbocation is obtained. Okay. Unfortunately, this carbocation from this particular example, randomly I selected in order to say the correct steps of mechanism. That cation formed is a primary cation, and we know compared to primary, secondary is more stable, and again tertiary again stable. So here there is a chance for the rearrangement. This methyl group is shifted, and that is called as methylide shift, CS3 minus shift. This CS3 group is joining with the positive carbon, so that a positive charge is created here. So there is a change in the structure of the cation. This carbocation become in this way. The main advantage, primary site is shifted to tertiary, and from here a molecule of H+ is released. So in this step we are following sets of rule, because with respect to this positive site, these three are beta. This is alpha, beta, beta, beta. So when we are removing one hydrogen from here, double bond is formed in this way, and these two locations are identical. When we are removing H from here, double bond is formed at the interior. According to sets of rule, most substituted alkene is the preferred product. So this will be the location of detaching H+. So after removing H+, the product formed is CS3, C, CS3, double bond CH, single bond CS3. So this is the total mechanism. Okay, and you can identify first step, okay, and answer that particular question. So question number 7 is over. Question number 8. A secondary alcohol is given, and CrO3 is an oxidizing agent. Secondary alcohol, when oxidized, you are getting a ketone. CrO3 is an oxidizing agent. Why? Because chromium is in the highest oxidation number, +6. That is the reason. Ketone is the option 2. 9th question, orthonitrophenol and paranitrophenol are separated by. Actually, you are studying this concept in chemical bonding also while discussing the area hydrogen bond. Orthonitrophenol is connected by intramolecular hydrogen bond and para by inter. Inter means mutual connections are there. Intra, no connection with other molecule. It is a discrete molecule. So automatically, when we are passing steam through a mixture of ortho and para nitrophenol, orthonitrophenol is moving along with the steam. It is steam volatile, but para cannot. So steam distillation is the perfect method to separate ortho and para nitrophenol. Okay. Question number 10. Alkoxide and alkyl halide react together to form an ether. That reaction is called Williamson synthesis. Question number 11. Tertiary butyl iodide react with the sodium ethoxide. It's an extension of Williamson synthesis. Remember, in Williamson synthesis, it's a short form. It's my version. Halogen never be connected to benzene ring or to tertiary carbon. We are discussing, okay, the formation of ether. Okay, so halogen when connected to tertiary carbon, you are not getting either as a major product. Okay, halogen when connected to benzene ring, there is no reaction at all. We know aryl halides are less reactive. It is not able to react in this particular condition. If it is connected to tertiary carbon, alkene is the major product. So these are the two precautions when we are studying Williamson synthesis. You have to remember. Halogen never be connected to tertiary carbon. If it is connected to tertiary carbon, a reaction happen, but alkene is the major product. And if it is connected to benzene ring, no more reaction at all. Here the question is connected to tertiary carbon. See, what is the question? When tertiary butyl iodide, what is tertiary butyl iodide? Okay. CS3C, CS3, CS3I. This is tertiary butyl iodide. halogen connected to tertiary carbon, react with the sodium methoxide, Na plus O C2H5. Agree? See, this NaI detach, and this C2H5O join with any of the hydrogen from the beta position. So you are getting CS3, CH2, OH also. So when I is removed and one hydrogen from any location, because these three locations are identical, you are getting a double bond here. Here or here or here, all are equivalent. So the product is, I am writing this way, isobutylene or 2-methyl propene. 2-methyl propane, answer is isobutylene is common name. Question number 12. Oxidation of phenol with the chromic acid produces parabenzoquinone. Okay, it's a reaction directly given in NCERT. What is parabenzoquinone? Quinone, that is enough. This is the structure. Then question number 13. Order of the reactivity of alcohol in esterification reaction. Let us analyze esterification. I told you yesterday alcohols undergo two types of reaction. Reaction in which H detached and OH totally detached. If H alone removed, that follows the order primary more than secondary than tertiary. If OH is totally detached, just like dehydration, tertiary more than secondary than primary. Okay, so let us analyze what happened in esterification. Carboxylic acid react with the alcohol in presence of concentrated sulfuric acid. A molecule of water is removed. So confusion, whether water is removed in this way, that means H from acid and OH from alcohol, or OH from acid and H from alcohol. And that is established by a labeling technology. Alcohol oxygen is replaced by radioactive oxygen. Alcohol contains an OH and that oxygen atom is replaced by radioactive oxygen. Okay, and that technology is called labeling. Okay, and after conducting the reaction, see the product is RCOOR dash. This radioactivity is retaining with the ester. That means oxygen from alcohol is not participating in the formation of water. That means H alone will detach from alcohol and OH from carboxylic acid. So with respect to alcohol, it undergo a reaction in which H is removing. Okay, H removing reaction, the order will be primary more than secondary than tertiary. So identify an answer, primary greater than secondary than tertiary. Okay. Question number 14, order of the reactivity of alcohol with the PCl5. Okay, PCl5, see ROH with PCl5, actually it is PCl3 plus Cl2. Okay, this oxygen combined with the PCl3 to form POCl3, H joined with the Cl to form HCl. So you are getting RCl. Anyway, my argument in which in this particular reaction, OH is totally detached. OH detaching reaction follows the order tertiary greater than secondary than primary. So find that option. Question number 15, A gives B, zinc is the reagent used, and B when soda lime distillation you are getting benzene. What is A? So let us proceed from the back side. Let us proceed the reaction from back side. Okay, see. A compound A, B gives benzene, and that benzene, here zinc heater, here soda lime, NaOH plus calcium oxide. So soda lime decarboxylation you are getting benzene when this molecule is benzoic acid. Okay, or sodium salt of benzoic acid, B. And that B is obtained by zinc, means zinc is actually used with respect to aromatic compound, removal of oxygen from OH group. Sudden O will be removed when we are heating with the zinc. So definitely that molecule contain an OH group and COH. Okay, good idea. So salicylic acid may be the answer, or hydroxy group is there and COH group is also there. That is the structure of the original molecule A. I am not sure whether it is salicylic acid or not. Anyway, let us analyze the answer. Yeah, salicylic acid is there. That molecule benzene ring should contain at least one COH group and one OH group. That OH group is changed to hydrogen by treatment with the zinc, and the COH group is removed by treatment with the soda lime, then only you are getting benzene. Agree? Question number 16. Ethoxy ether air, the product is. See, either when exposed to air, either peroxide is formed. It's a dangerous thing also. Peroxide containing either when exposed, okay, it immediately catches fire leading to explosion. Okay, so in organic laboratory, not inorganic, in organic laboratory we are not using water as the medium, normally we are using ether as the medium. So precautions should be taken, okay, otherwise there is a chance for the explosion, okay, fire like that. So diethyl peroxide is answer. Question number 17, Friedel-Crafts reaction of phenol was using methyl chloride anhydrous AlCl3 produces. Phenol is an ortho-para direct. Okay, so phenol when treated with the CS3Cl AlCl3, what happened? Phenol is an ortho-para direct. So when it is treated with the CS3Cl AlCl3, Friedel-Crafts alkylation, you are getting orthocresol and paracresol. Okay, orthocresol and paracresol both are formed. Para will be the major. Here there is no word major product. Friedel-Crafts reaction of phenol with the methyl chloride and anhydrous AlCl3 produces orthohydroxyl toluene. Yeah, that is also correct. Orthohydroxyl toluene, parahydroxyl toluene, orthocresol. Everything is same. All of this. Salol, widely used as an industrial antiseptic. What is salol? You know, salicylic acid were subjected to. Salicylic acid, you know, it's an important chemical, especially in allopathy. Salicylic acid when treated with the phenol. This is salicylic acid. This is phenol in presence of concentrated sulfuric acid. Okay, a molecule of water is removed. Acidification happens to form phenyl salicylate. Okay, COOC6H5. That phenyl salicylate is commonly called as salol. Phenyl salicylate. Yeah, option is phenyl salicylate. Okay, moving to question number 19. Hydration of 3-phenyl 1-butene with a dilute sulfuric acid mainly formed. Let us write hydration means adding water. 3-phenyl 1-butene. Let us write 3-phenyl 1-butene. One butene means double bond is at the CH benzene. This is 1, 2, 3, 4. 3-phenyl 1-butene. Okay, this molecule we are subjected to hydration means adding water. So first step H plus addition. So this H plus join here. So pi bond is shifted here. Sorry. CH3, CH, benzene ring, CH with the positive becomes CS3. Agree? So this is the cation formed. But here there is a rearrangement once again. See, this is secondary carbon and this is tertiary carbon actually. And also benzyl carbocation formation is also possible when this positive charge is shifting here. Agree? Compared to benzyl and secondary, benzyl is more stable. So again one more H is shifted as H minus. Hydrate shift happened. So the intermediate has this structure. Agree? Okay. Positive charge is shifted to the carbon connecting benzene ring. Then it is further stabilized through resonance. And this is now joined with the OH minus. You know, of course, positive and negative join together to form compound CS3C with an OH group, and that carries a benzene ring and CH2CS3. That means 2-phenyl 2-butanol will be the answer. 2-phenyl 2-butanol. Let us see. 2-phenyl butanol 2 or butane 2 option 2. A good question. Okay. So carbocation, if possible, rearrange from primary to secondary or secondary to tertiary. Keep in mind. Clear? Question number 20. Alcohol that cannot be prepared by the addition of Grignard reagent to carbonyl compound followed by hydrolysis. Answer is methanol. Why? Because carbonyl compound at least contain one carbon and Grignard reagent at least contain one carbon. So Grignard reagent carbonyl compound combination produces at least ethanol. Not able to form methanol, that is answer. Okay. So all the questions are over. So these are some minimum information from the chapter alcohol phenol. Either study it thoroughly. Moving to the next chapter, that is aldehyde ketone and carboxylic acid. It's actually a continuation of this chapter. Every chapters are connected. Okay, so study well once again. Okay, two more organic chapters left behind. One is aldehyde ketone acid and other is amine. Okay, so most of the chemistry important areas that will be finished. Then biomolecular is very easy idea, especially your biology students. Inorganic is I told you to study inorganic just like biology. Read line by line. S block, P block, D and F we have discussed. P block is a long area. First year is first year 2 group, second year 4 groups, 15, 16, 17, 18. So that you prepare yourself. We have discussed so many questions and we taught you in detail. Okay, so the next duty, that is your part. Read it thoroughly again and again. That's all. Okay, stopping here. Namaste.